Hello YouTube family, James Green, Short Serious Shenanigans. So this is going to be episode number 2, if you will, of the Holdridge Radii grinder. Today we're going to actually show you some hands-on stuff. Now, I know in the first video I had a lot of people comment, why wasn't there a hands-on? As you know, I do my videos in 30-minute segments. So that was basically an overview. I am going to talk about today things that I've run across. Again, this is the first time I've owned one of these. I've had a chance to talk to other people since uploading that other video and had some very, very good conversations. Again, I've got a lot to learn about using this piece of equipment. So what I'll do is I'll go over today and I'm going to show you guys, and I do talk a lot during my videos, and the reason I do it is I want to explain to you things that I've run across, nuances, little quirks, and you may or may not have the same issues with your lathe and your process. But I am going to talk about my experiences, and the material that we're working in is 304 stainless. So for those of you that are new to metalworking or not familiar with, stainless steel in general, as far as can be difficult, especially 304. You have to use carbide inserts or tooling to work with it. High-speed steel will not work well in it at all. It'll eat it up. The nickel content and the way it's made and designed, it just eats tooling, period. So even insert tooling, drill bits, if you're not careful and you're using proper lubricants, one of the lubricants that I like to use, it's out there, and a lot of you guys may already know about it, it's Anchor Lube, you guys. This stuff is good. Matter of fact, my buddy Stan Zakowski, Shadon HKW, card up here to his channel, okay? You can actually get a hold of him. He sells the stuff, a fellow YouTuber. I got a bunch of it when I was out at the Summer Bash this year because I'm always working in 304 stainless. I don't know why, it's just, they're like, here, you're going to get to do a lot of stuff in 304, which is fine. I've learned a lot about it, and I will say this, using this, and if you're going to work in exotic materials, hards, milling, drilling, tapping, lathe turning, this stuff, Anchor Lube, and it's actually food rated, health rated on the back. So if you're working in an area where there's food grade stainless being involved, this is actually approved to be used in food grade according to MSDS. If you guys have any information, go on anchorchemical.com, Google them, pull them up, go to their website. You can even get free samples. But this stuff is great. What I did was, because I got a lot of these little sample bottles, is what I'll do is I mix like a 50-50 here in a little tray. This is something Stan showed, and it's a great idea, is getting you a little tray, these ones from Harbor Freight, and I'll put some out here and I'll mix a little water 50-50 so it's not so sticky, if you will. Not sticky, but it's a little bit thinner, and you can add water to it. It cleans up. It's fantastic. So I'll usually keep a little, because those just press on. So anyway, what I'm going to continue to talk about, and again, you guys, if you have any questions, constructive comments, questions in the comment box, or if you guys want to email me, eagledustoff37@gmail.com. I'm also on Instagram and Twitter. I post stuff up there. It's at eagledustoff37. So I will go ahead and I'm going to explain to you what we're doing is, so I had a friend of mine, and description box below, his name is Dan Leduc. So he's up in Michigan. He asked me, he's like, hey, I need some of these made. So my understanding is these are like a mirror mount, okay? It's a cast item. You can see what's left of the cast sprue on the sides, but they break easy, and as you can see, they oxidize. So even when you measure this, it's not symmetrical, even on the ball and everything. So what I did was, he's like, hey, can you make me some out of 304 stainless? So I purposely made these just a couple of thou longer and a little bit bigger in the diameter. So the way I've approached this, and it was to experiment how to get your machine set up. Okay, so what I ran into was, and we talked about, you can turn the camera down. So let me move you guys over here. Okay. So you get a better view. All right. So, what you can do, and what it does show, is you can pull your tool post off and put it onto here, okay, with that little plate. Now, I may try that in the future, but for now, because I wanted the ability to be able to fine adjust, I'm going to have to go through a lot of time. I'm going to need to build a bigger plate that goes in here, and I may do that in the future, but for right now, and then I'm going to have to build a specific height block to go in here. And I didn't have time for that. Like I said, I already had this bar. I put it in the quick change tool post, so I can fine adjust. Now, with that being said, what I talked about in the other video was making sure everything's tight. So what I did find out, and I have everything relatively snug here. I have my gibs on the screw. There's actually a screw here for the cross slide. Okay, you actually tighten that, and that takes a lot of tension out, because once you get the tool centered, okay, let's go ahead and throw this in here real quick. And the reason I'm explaining this and doing a lot of talking, guys, anybody can show a piece of metal being turned. I want to explain what I ran into and what I've experienced, so that way if you guys purchase one of these, whether it's new or used, or you get the opportunity to use one, you're going to be ahead in knowing how to use it. Again, there's lots of videos out there. Everybody does it differently. So what I did is I went ahead and turned a bunch of the material down to a little bit oversized the final dimension that I needed for the ball on this. Okay. Our dimension that we want to reach is 716,000. Approximately, give or take a thousandth either way is okay. So I actually turned these down to like 725 approximately. So that way, whenever I got down to the end to do the fine tuning to get it down, I didn't go under. Now, I tried to set it to go like 720 immediately and thought, okay, well, I want to get closer. Well, in the process, I found out when I was talking to you guys, getting the machine set up and the flex and the way the tool digs in and every little pass, there's always going to be a little bit different. So I thought, well, let me go ahead and leave it large, and so that way when we're done and we get down to, because first we've got to turn a bunch of them, and we're going to do this operation second. Okay, so we've cut everything, we turned everything down to a large diameter, then we've cut it to length, and then we've done this, and we've got close to our dimension. The next step is going to be, I'm going to pull this off, and we're going to come in here, and I'm not going to show it on video, but I'm going to come in here with this other tool here, DNMG insert 332, and I'm going to come in here, and I've got to create, using that tool as well as this tool, okay, it's an SNMG insert, to be able to come in here and create this area, okay, and then to get that chamfer angle in there. So a couple of different tools, different operations, and plus finally when we go to hold this, we're going to hold it here, and I've got to make a little hole on the end of all of them, which I haven't done yet, so I can hold it and support it. And then the final thing is to turn this diameter down, because right now this diameter is large and this final diameter is smaller than the other. So several different ways we have to approach making these. So that's why we're doing what we're doing. So first we'll go ahead and load material in. Now, I'm always talking about 5C collet chuck. Having a standard collet with the jaws out here, whenever you get back over here like this, okay, and you have a short piece of material, a jaw is going to catch this really, really, really easy. So this is another example of why it's good to have a 5C chuck for your head. On these Grizzly Lays, it's a D14. You can get them from Shars. Matter of fact, the part number on this one here, because it's still on it on the outside, I believe. I can barely read it if it's still there. Or did it get scrubbed off already? It got scrubbed off. But anyway, actually, yeah, I can barely see it. So, but you can get them at Shars, and it runs great, guys. This thing runs virtually dead flat. Now, I have determined if you guys have this machine or one to it, the best speed that I've determined for running this is about 460 RPM on my machine. If you have something that's close, that will work. I've done slower, I've done faster. All around for performance, I found that works the best. So we'll go ahead and slide this over here. We'll put our piece in. And there's no specific depth that it has to be. Generally, I try to get about, I'll usually hold it and get about 1 inch in approximately. That seems to be working good enough. And I've turned these down, and we're holding everything with a 47/64 collet. Okay. Alright. And the reason I made those short is I didn't make these really, really long because you don't want to be able to get too much leverage and break something. So I purposely made these short. Having long handles on your, I have found out on this smaller stuff, you can break stuff getting too much leverage. So right there, short, it holds good, it does the job. 5C works great. So what I was talking about, because once you get, and this right here is the amount of backlash that's naturally in my machine. It hasn't changed from day one. It's always been the same amount. It's about 12 thou, 12 to 14 thou, which is fine. I know where that is. So you have the gib adjustment screw here. What you do is you get this set up, and once you, I'm going to zoom in here so I can show you guys what I'm talking about. Alright, when I talk about finding center, okay, first what I did was to get my tool depth set up. I've talked about this, okay, and it shows you on the box. You take your, let me pull it out here. I already put it up because I had it set. So you've got 2 flats over here, okay, and what you're actually supposed to do is use your depth micrometer, and you use a 1 to 2, and it fits out here. You set your depth and you come in and with your math and you determine the size of the radii you want. Now that's what it shows in the directions. You know me, how can I make it simple to where to pull the math out? Because sometimes, you know me, I always had trouble with math growing up. I had a really crappy math teacher in high school and junior high, so that was something I always struggled with. So to make this simple, and it's just a different way of doing it, what I did was, because I know I'm down to my approximate diameter, okay, now to start off with, we know we're close to it. So to simplify this, and again, this is another way to do it, what I did is I got down to the dimension of my tool. Now, you want to make sure when this is over here that you're centered, that you're coming up on your center point. And I'll try to get the camera in here to where you guys can see it. So we have our tool height set, and we got to make sure that our cross slide is in far enough. We're not going to be messing with the compound. It's locked down. The gib's tight. We've got the slack out of it, and we've got it really, really tight here, because we're not going to be moving the compound of the cross slide. All we're going to be moving is the carriage and this handle. Okay, so what you need to do is, you can see the center of your material, and you can figure out when it sets as it's spinning what center is. Okay, so you've got, and you achieve that. Okay, you get this centered, you move your cross slide across until you've achieved center. Let me zoom you guys in so you can see what I'm talking about. Okay, whoop. Again, what I'm showing you is just a different way of doing it. So we've got our center height, and this is where it's critical that you take all the slop out of your gibs on your compound and your cross slide. So your center height, just like you do your tool height, and this is where having this tool comes in handy again. I've showed this before. Okay, let me back out. Okay, this was very handy and instrumental in setting my tool height. I was able to come in here when I had everything set up before I swung it over to the side and set here. That sets on the insert, and I got my tool height. I came over here and I just did a little bit of fine adjustment We got it set, we got it locked down. So the next thing is you move your cross slide across until you're centered, okay? All right. So the next thing, and at that point, you essentially want to lock down. And what I did was, so that there wasn't any play, because this is something I experienced when I used the initial insert that came, is I still had so there was enough flex in here and give between the compound and cross slide that the tool dove a little bit. Even turning stainless or whatever material, the tool has a tendency, especially when you get around here on the end, when you're transitioning from your side around here to the end, there's a lot of tool pressure. And it's just, you're sticking out here quite a bit away, so there's a lot of leverage. You're not close up to the tool post. So get your slack out on your screws here, your compound, your cross slide, tighten them up. You're not going to be moving them. You reset them when you're done with your tool. When you go on to your next operations, you can back this off a little bit. So I generally leave my compound really snug until I'm going to use it, and then I'll back it off just a little bit, just because I don't want that play in there to be a factor to break an insert. So you got that. So what the next thing I did is, once I got my depth here, regardless of how far this is sticking out, so what you do next is you swing it over here at 90, you loosen your screw, and I've got it set, so I moved it in here to where it touched, I tightened it down, and then after doing a few turns, okay, make sure you guys can see this here. I'm trying to make sure I get it in the camera. So what I did was, I came in here, I touched off, tightened my tool down, did a little bit of a turn, and then I determined I wanted to go a little bit further, so I actually slid it in. And you can do this by eyeballing it, or however much you want exactly. If you know you want to be able to work it down, which I'm going to come back later and set this in even further, or you're going to work the part down with a file or other abrasive material, emery cloth, whatever. So I chose to do it this way, and we're a little, so that's just a simple way of having to do a depth mic. You can pull it out, you turn your material with your micrometer too, and then you can come back and there's a lot of handcrafting involved with getting down to this. Now obviously when you're doing this, even set up this way, the machine, there's still a little bit of give and there's still a little bit of slack, and you got to take all that into variables. So my advice is, don't try to cut it too close to the final dimension that you want, because you'll go under. Because I did that mistake about 3 or 4 times, and I thought, okay, wait a minute, let me back the tool off. The material is turned bigger than what I need. I'll sneak up on it slowly. Your machine's going to be a little different. The wear even in the carriage on every machine is going to be a little different. So experiment with your machine and you'll see. So I'm going to back you guys off. We're going to walk through it real quick. And we got a new piece in here, and I'm going to set you back over here. I'm going to try to get you guys a good angle so you can see this. Actually, I'm going to leave you right there. And I'm just going to go through the motions here. Now, noise warning, because it's stainless and there's a lot of high-pitched squealing, so get ready, turn your speakers down, because I don't like hearing the high-pitched squealing. Even though I do have hearing aids, I'm going to be putting these on. So noise warning when you go to cut. So we'll get our anchor lube over here and we'll go ahead and get started. I'm going to leave you guys right there. Let's go. We're going to take little bitty cuts. Once you get your burr started, keep moving with it. Don't stop. And you don't want to go too deep. I will say this, what I found out cutting 304 is if you, because all you're doing, you're not changing your depth. All you're doing is you're sliding your cross slide over. Is if you start cutting out here to bring your depth more, you just slide over. Start cutting here first and move in. You'll be less likely to break an insert. I just wanted to stop and tell you that. Let me go ahead and keep going, I'll show you. So there you guys got to see what I was talking about. Let me go ahead and flip it over and I'll do the other one real quick because I know we're limited on time on the video here. We got about 9 minutes left. Alright, just rotate. And this one I'll just go ahead and go through at full speed. I'm not going to stop and I'll show you how it works. Again, starting out here doing the main cuts, because if you start in here it tends to want to grab and it'll break the insert. So start out here, it just cuts better, it's less likely to chatter. So here we go, noise warning again. I'm going to go ahead and actually, I'm going to move you guys around here on the end for this one. Get the camera set so you guys can see it from see if I can get you guys a good angle. If that'll be a good, take a look here, zoom the camera in. Nope, tool's right in the way. So, actually, let me try. I'm try moving the camera right over. There we go. Okay. I bet that'll work. There we go. I just need to move the deal out of the way and you guys will be able to see what I'm doing from there. We go. Alright, good angle right there. Alright, here we go. Hopefully you guys got a really good view of that in there. So, there you go. Yeah, that high-pitched chalkboard squealing noise, because we don't like it. So, the object is, we're going to be making some of these, and there's other operations that involve other tool turning. Matter of fact, I completed one. This was the first one I did when I was trying to figure out, and when I was trying to figure out all the operations I needed to make everything. And it's always the first one you do of figuring everything out, of how it's going to work, how it's going to look in the end. So, again, what I have learned from using this is making sure your gibs are tight, because all I'm moving literally in the machine is the carriage. Because once you have your depth set of how far the tool is to center of the stock, okay, and your tool height, literally at that point, and then you have your tool set for the diameter of the finished radius. And what I said I learned was, even when everything was fit tight, I still, if I tried to set it and turn it to the exact, you got to sneak up on it. That's what I learned. And I'm using 304. You guys know, as soon as that you start the burr, keep going with it. And what I've learned is, and I'm using a 332 insert on this, you can buy the inserts, or you can buy the tools from them, you can make your own. But what I have learned was, moving the tool, once you get the burr started, you notice once I got around to the end how it started really chirping and jumping. You just keep going, because you're changing where the tool is cutting from on the end to on the side of it. So there's a lot of weird stuff going on there. You just go with it, keep your burr going on 304 or any material. Once you got it going, just go with it. Listen to your machine, get the feel. The more you practice, the more I use this, the more I understand it. Again, this is a universal. It fits 8-inch swing to 13-inch swing. This particular model does. And so hopefully this video has been very, very helpful to you guys. If you want to make you a radius turner, you know, a lot of the same principles are still going to apply. I would imagine, you know, every piece of equipment is going to be different depending on what you put this on. So hopefully, if you've got a machine similar to mine, or you've got the same model, hopefully it's helpful. I know I've had a lot of people here in the last couple of years purchase the exact same machine I have. I am running at 460 RPM on my machine. We know it's a little faster than that. The 5C call it, you guys, I love that. And so hopefully this has been helpful to you. If you guys have any questions, please comment below, email me, contact me. You can get this at All Industrial. Contact them. Request a master catalog, you guys, right before Christmas here, the week before Christmas 2016. I want to give a big shout out and a thank you to all my fellow YouTubers out there, you guys. Merry Christmas and Happy New Year coming up. Again, thank you to All Industrial Tool Supply, Jeff Perry, Jim Henry. You guys are awesome. When you call All Industrial, ask for Jim Henry. He's a fabulous guy, really super nice. Again, shout out to Empire Abrasives, you guys. I love your product, as well as American Rotary. You guys are awesome. Thank you, thank you, thank you. All the people out there, all the garage guys and gals, you know, this is a phenomenal community that we have. Keith Finner and his toolbox giveaway. I'm glad to see everybody you know, get those tools. We have an awesome community. Again, thank you. Merry Christmas from Albuquerque, New Mexico, United States of America, to around the world 2016. Until next time, you guys and gals, take care of yourself and take care of your family, because remember, at the end of the day, you and your family is all you got. Till next time, get out in the shop, play with a radius turner. This stuff is fun. I'll talk to you guys later. Bye-bye.